Righty-ho. This is my third attempt now at doing this question because it's pretty tricky. Even though I wrote it, I keep getting mixed up and found a quicker way or something. So, right. There are different ways of doing it, but I'm going to try and do it a kind of a cool way. So what's actually happening here? We've got a charged capacitor. And when we close the switch, some of that charge is going to end up on this plate. So in other words, the capacitance goes from 2 to 9 microfarads because of the extra 7. And when you can add the capacitances when they're in parallel. The charge is constant. So I'm going to work with those two. And the equation that I need for the energy stored on a capacitor, therefore, is half Q squared over C. So the change in the energy, that's the wasted energy, that's going to be a half times Q squared, which doesn't change, times the change in 1 over C. Right, so I'm just gonna put those numbers in now so you can have a look. I've got a half times, and the charge is 58 microcoulombs. That's 2 times 29. So I've got half times 58 times 10 to the minus 6 all squared. And I'm going to times that by the change in 1 over the capacitance. So it's 1 over 2 times 10 to the minus 6 minus 1 over 9 times 10 to the minus 6. And that's going into the calculator. So a half times 58 times 10 to the minus 6 squared times 2 times 10 to the minus 6 to the minus 1 minus 9 times 10 to the minus 6. And that gives me 6.5 times 10 to the minus 4 joules.